our focus for today is to discuss state management called Mobx and how you can use it for your Flutter applications. Uh, whether you are working on a simple Flutter application or even on a real Flutter project that needs scalability, Mobx works great on all kinds of complexity of the projects that you're working on. And our agenda, like pretty much straightforward, just discuss high-level overview of what state management is in Flutter and how it works um, no, in context of Flutter, state management using Mobx, how you can use Mobx for your Flutter applications, and some practical examples we will do during the live coding. Okay, so if not the most important, at least state management is one of the most important concepts that you have to understand whenever you try and build a new Flutter app or even on other platforms such as Android and iOS. And one of the key concepts that you have to understand is determining what state is in your app. So this helps you define how to model your applications and even how you can design the UI or UX of your application. And there may be a lot of definition what a state is specific to the platform, like Android, iOS, or Flutter, but description, like I consider state as the data that I interact with and my user interact with using my app. And formality state is just the things that you use for you to be able to show the appropriate widgets, the appropriate UX, such as for the prompts, such as the error messages, to being able to react to the users of your application. And state can be as simple as scalar data such as strings and booleans. Mostly these are booleans that you use whenever you try to hide or show something in your Flutter app, or even a complex data structures such as lists, maps, or sets when you are dealing with multiple set of objects. And last but not least is state is something that should be managed properly because our app is supposed to be reactive by default because that's how our users use our app. Users are reactive by default in a way that if they've seen your app, they might be touching your bottom app bar, your app bar, your navigation app bar, and a lot of objects in your app. And you, as your developer, you should be able to react to this interaction of your users so that you'll be able to give them a good user experience, so that they won't be expecting something that probably won't be showing up because it's kind of like the wrong user experience that you've kind of like gave them the intuition from. And this is probably the most controversial question and most asked question in Flutter, but really, what is the best state management for Flutter? If you are here, to identify what is the best state management for Flutter, sorry, this talk is not for you because there's no such thing. There's a lot of things going on in determining what's the best state management for everyone and for every project that most of us will have to work on. And several factors include such as we all have different timelines, especially if you're working for a consultancy company. Like you may have different projects that have different due dates, deliverables in terms of priorities as well. And in terms of the developer experience, this can be highly subjective, whether your team is coming from a web developer experience or a native developer experience. They have varying experiences, and Mobx might work great for a team. Block might work great for a team, but there are some instances that things doesn't work our way because there might be some differences on several more factors on top of our experience. And a lot more to it, like expertise, whether you are coming from other programming languages such as JavaScript. If you're already familiar with Redux or Mobx, then you'll probably want to try the same state management and the principles behind Mobx or Redux if you're trying out Flutter. And also for the complexity of the project, if it's a simple application, like there's no point like using much complex state management if you're just building a simple hello world app or counter app. But on a real Flutter application, you really just have to use something that is widely used by the community or backed by a lot of big companies that support it in open source. And like from my experience, Mobx works great if even if you're working on a simple app and at the same time working on a real project. And it's built to be reactive. So as mentioned earlier, users are reactive by default. They interact with your app at any given time, and you should be able to send some response to them, whether you're showing a dialogue or showing some error messages whenever the user requires to see that, so that they'll be able to understand what's happening in your app. And Mobx is based on these core principles, what we call the triad in Mobx. They are the actions, the observables, and the reactions, which includes side effect. And we'll be discussing them in detail in a few. And as well, like Mobx is backed by the community. The creator of Mobx for Dart is Pavan. He's worked directly with the creator of Mobx for JavaScript, which gives us this really healthy community of developers that supports either of the implementation of the interfaces for both that will work great across the Mobx implementation on different platforms and languages. And the Mobx Triad is really, let me just switch that. Okay, so the Mobx Triad is based on these uh, three things, at least the three main ones. The first one is the actions. So the actions are think of it as the way for you to create the business logic of your application, such as calling external services such as RESTful API, GraphQL mutations, or like connecting to WebSockets. And these actions allows you to update the values of the observables. And with these actions, like it's optimized by default. If you try to call a specific function inside a single action block, every time you try to update an observable, for example, you have 3 observables, the notifications will only notify the UI when when you finish loading the last observables in that specific action block, which is optimized by default because you don't want to rebuild the UI every time you try to update an observable, especially if you're working on a lot of API chaining. And with action, you can do this using a single block, but at the same time, you can mutate observables directly by changing or calling them dot counters equal to 0 or 1, and you'll be able to see the reactions for every change that you make. Although one of the benefits with using actions, it makes a bit more semantic, and in contrary, without using the action block, notifications are sent for each of the changes that you've introduced, the observables, which is kind of not the thing that you would like to have, because most of the time you will have to do a lot of logic inside an action block. For example, calling, calling some analytics functions. Whenever you try to invoke an API call, you would have to typically chain an API and more. And next in the triad are the observables. So to put it simply, like observables are just the data that is being updated and being observed by the UI or some side effects that you have in your app. And observables can be of different types, such as simple scalar values, such as int, double, or number. And every time you try to update an int or double, the reactions or the side effects will have to re-render themselves so that they'll be able to display the appropriate state of the application. We also have strings and booleans. Booleans are mostly used for flags, like showing or hiding a specific element, or lists whenever there's an item or not. We also have lists, complex data structures such as lists, maps, and sets. Sets are the difference between sets and lists is that sets contains unique elements. At the same time, maps contains key value pairs in Dart. And observables can be broken down into 2. So the first one is the core state. So these are the observable values that you would typically have to update inside an action. So inside an action, like if you have, for example, an API call that updates the first name and the last name of the user, they will have to be the observable values. On the other hand, derived state are the read-only values, which reacts to the changes in this first name, last name, or age, and they are only read values, so they can be considered as well a reaction on top of being an observable. And a core state, no, they are the observables, which we annotate observable. Later, we'll see this in action. Derived state is what we consider the computed observables, in which they can be based on a core state, or a core state plus a derived state, or even just a simply derived state. And for example, like this full name, if you don't want to create a function that, that, for example, get full name, you can just simply have a getter function that gets a full name for to compute the value of this if you try to combine them together. At the same time, if you want to combine a core state to a derived state, then you can also do something like, for example, you can use it as page title of the page or what. But yeah, that's the cool thing about Mobx, is that it allows us to do computed observables. So probably computed observables are one of the most underrated features of Mobx, but really, like, this is one of the most, if you're looking at it, some of the projects I'm working on, this is probably one of the things that you're probably using instead of using pure functions. And last but not the least, what completes the triad are the reactions and some of the side effects that you can do to the observable value changes inside your Flutter app. So the first one is, for the side effects, you can do like use these APIs from the Mobx package, like auto run, meaning like every time you try to call this auto run, it automatically checks the value of the observables from the very beginning, or like from the very beginning that you call that specific function. We also have reaction, like every time the value changes from an observable, they get, this reaction invokes the method inside it, the side effect. And the only difference between when and async when in a reaction is that when and async when are only called once. So whenever you have some initialization, such as an API call for a specific detail page, then you'll probably want to just use when or async when. And the difference with async when and when is pretty much async when gives you the capability to handle asynchronous operations. And you'll see later in action that Mobx really allows you to do tracking of the observable changes, like automatically. Like that doesn't have to be explicit. Like you don't have to wire things up on your own. You just have to call the value, then that specific side effect will react to the changes in that observable values. And in Flutter, now from my experience, like, you would just have to mainly use reaction and observer, at least from the specific package. And before we start, just a few notes. Like before you start using Mobx, these are the official dependencies that you can use for Mobx. This is the Mobx CodeGen, which allows you to implement the equivalence observer pattern of the store file using the annotations for the actions, observables for the observable values, and computed for derived state actions. And by default, as mentioned earlier, we have the Mobx CodeGen package, which allows us to simplify things on implementing the observer pattern. So one of the cool things here is that Mobx has a low level of probably barrier in terms of an easy learning curve, because instead of you not knowing how to implement the observer pattern, you can just simply wire things up just how you do things if you try to keep things or keep the state local. So one of the cool things about Flutter is that in Mobx is that it has this code support for code generation. And as mentioned earlier, we have the annotations that helps us, especially helps the code generation to identify which amongst these specific variables or functions needs to be implemented in a way that it follows the observer pattern, which Mobx is based on. So without further ado, let's start with the live coding. So one of the few examples here, if I try to run example 1, I'm not sure if can you guys see it. Like, let me just try and zoom it a bit. Okay, I think that works great. Okay, can you increase the font? Should that work fine? Like, okay, great. Okay, so right now I'm running the example one that I have here. So we have three examples here, which comes with varying complexity. The first one is just a simple counter app, which is an equivalent of the typical Flutter project that you would have to create if you run Flutter create function. So in here, like I just have a button, a floating action button, and every time I try to press this, like it just has this function called increment counter. And I hope that noise doesn't disturb you. Yeah, for some reason there's. Okay, let me just give that a moment. Okay, we can continue. All right, yeah, you can also put it in full screen. All right. Okay, so the first thing that we can see here is the store file. So the store file is basically where Mobx Triad is mostly placed, in which computed observables, observable values, and the actions. And this is where you mostly interact with your UI. So in this app, like we have an example app here that provides the instance of the counter store. So provider is you're not familiar with provider, is just a mixture between a dependency injection and at the same time a state management. But in this specific case, we're just trying to provide the value of the counter store down the my home page, and we try to retrieve the value of the counter store from this specific point and did change dependencies. And the entirety of our code here is pretty much you just have push many times, and we have here the observer. So the first thing that we have to consider is the counter store. So as you can see here, we have the counter store value. What if we want to create convert it to double, and we have to create a new function? So for example, like right now, the only functions that we have here is increment counter, which is currently being called here. Is every time I press the floating action button, it just calls that function increment counter. What if I want to specify another function that decrements the value that we have here in the counter? So one thing that you can create is to just simply create a value decrement counter minus minus. And right now, this should just be fine, but it won't work even if you try to call it. Why? Because Mobx depends on, again, code generation for the store file, which allows you to forget on how you wire things up to implement an observer pattern in your Flutter app. So as you can see here, this is the auto-generated file. You can pretty much see here how the notifications are happening under the hood. But as mentioned, like Mobx really has a easy learning curve, which makes it easier for newcomers to try out Mobx by just simply using simple APIs such as these annotations that we see here. So let me just try and open up these. The one thing that I have to run is the command for code generation. The code generation is, you can pretty much see it on the packages that you will be using, the Mobx code gen, and you just have to enter. Then this should automatically updates and wire things up for us automatically inside this generated store file, which is the counterpart of the ones that we explicitly created. So right now it's running, and we just have to wait for it. So by the way, I'm running this command is running for the entire project, and I almost have exactly have three projects here. So that probably constitutes to some build times as well. Right now it's already built, and if we try to see the counter store, it should be here. Okay, so the equivalent in the observer pattern is already be in the counter store generated file. And to use it, we just have to go back to the UI of our app. We just have the scaffold, the title of the widget, And we just have to add probably another button here, raise button. This is how you add widgets in Flutter, which I'm not try to discuss it in detail, but this is how you do it. Just have to add raise button, call the function decrement counter. You can also do the shorthand method like this, since they don't have a specific parameter. But for the purpose of some demonstration, we'll just call it decrement counter. And we try to run it. Like, I just have to restart it. And we should have a button here, decrement counter. And now it's currently using double. So every time I try to increment this one, this should decrement the value as well if we have the button for decrement. And I can just split screen with that one. And one thing that you can notice here is that we have a observer that is reacting not to every time the counter value changes. So this happens because we have this observer. So as mentioned earlier, in Flutter Mobx, there is a specific widget that you can use to react automatically to the changes in the counter. So if every time this counter changes, you would have to subscribe to it using an observer. So this builder method, similar on other builder methods in Flutter, this gets rebuilt every time. And one of the benefits that you get here is that instead of you trying to rebuild the entire page, such as the entire page, including app bar, scaffold, one of the performance optimizations that Mobx provide is the granularity of the widget rebuild. So instead of rebuilding this widgets, you can just simply rebuild a specific portion of your application, which is, in this case, just the text that we're trying to update. And the other type of reactions that you can use in Flutter is simply a reaction function, in which it reacts to the value every time things are getting changed. So counter, have to import Mobx, and just have to import let me just try. I think for some reason, this should be good thing. Let me just, okay, so for the reaction, by default, it right now it should be double, right? So that's the issue. So by default, a reaction returns a disposable object. So one thing that you would typically have to do, similar on if you're using RX for Android, you have a reaction disposer, which can be off list, and you can nominate disposers. And for you to be able to dispose that reaction, you can have it disposed inside the dispose function of Flutter, which gives you a handy way of calling this callback. And for every disposer that we have, you have to destroy or dispose the object. So that's just the disposers for each object. You just have to dispose the object by calling the constructor of that specific disposable object. And in this reaction, what we're trying to achieve here is to just print the value. So print, hey, I receive counter. And as you can see here, if we try to run the app again, we now have two observers or two reactions that are listening every time the counter changes. One is this typical reaction function, and next is this observer widget, which is very unique to Flutter. So okay, let me just close that advertisement. Okay, and right now if we try to press this one, right now you can see here there's a print method that I received -2, I received -3, and that's how you typically work with the observable values in your Flutter app. And as you can see here, we are not wiring anything. We're just listening to the changes. So we're just telling our reactions that we have to subscribe to the counter value. And at the same time, in the observer widget, we are just telling that this observer has to change every time this counter value changes. which doesn't include any explicit wirings that this store should rebuild every time this value changes. It automatically built for you under the hood if you are using Mobx. So one mistake that we did here is that we are calling reaction, but we are not disposing it, even if we are trying to call here function. So one thing to solve that is to create an array, is to instantiate the array, and just have to call. So what happens now is, since this reaction is part of the disposers list object, every time this screen closes, then this just simply gets disposed as well. Right, so that's it for the very basic example of how observables works and how you can add more actions to your Flutter app using Mobx. Next thing we have to discuss is the computed observable, which is probably one of the best features Mobx can offer in your app. Let me try it. Yeah, it's just running. So the good thing about Flutter is you can set a couple of main enter points. So we have here 3 main enter points here. So you can see here example 1. We also have example 2 as a different application, but pretty much is still using the same dependency. Okay, it's still running. Give it a few seconds. Okay, it's running. So probably just a few more. So you should only expect this kind of like loading time from the very beginning, but pretty much if it's already built, you can do hard reload in Flutter. And I think it's already done. And yeah, now this is the example 2. So this is simple registration form, which is very typical to the applications that we are building for our users. So in here, we just have, let me just show you the code. Also, my laptop, it's a bit lagging, probably. Let me just close some app screens. And we have example 2. Okay. So in this example, like we just have a simple store, which is named registration store, which contains most of the functions that this specific form requires. Oh, it's a bit lagging a bit. So we have the first name as observable. We have some computed values, which we'll try to discuss in detail in a bit, and some functions that you can call for you to be able to mutate the values of the observables. And the pages here are just mainly 2 pages. So we just have the page for the registration page, which has a simple text field for the first name. So we have the text field for the first name. We also have the text field for the last name and a custom error message. So we have here an observer. Now, every time there's an error message or every time the first name is invalid, we have here a visibility widget, which reacts to this value that whenever his first name is false, you have to show this text, which text contains another reference to the observable values, which can either come from an API or an explicit error message that you have set in your store file. So these are the widgets. Let's try to go into our store file. So the first step that you'll have to check here if the functions are working. As you can see here, every time I try to enter more values, if it's under 3, then it will just show me an error message. The error message is reacting to the value or the length of the text that I'm entering. At the same time, as you can see here, the register button is still disabled. But when I try to enter a last name and enter a valid first name, then the button should react that it should enable itself whenever the last name and first name are both valid. So that's kind of like business logic, in our head. And in Mobx, if you're thinking like similar on how we approach this, checking if the first name is valid, checking if the last name is valid, then enable the register button. In Mobx, it's very straightforward to model the data of your application because you can just simply have an observable for the first name, which stores whatever value you've added and the text field. And we also have the computed value. And the cool thing about this computed value is you don't probably need to use utility functions or extension functions directly in the widget tree, but rather on the business logic part of your applications, which is the store file. So in this computed value, like we just reference this as a get variable, meaning we cannot set the read value here, but rather it just only reacts to the value of the first name. Whether if it's not null, then you have to check the length if it's greater than 2. If it's null, then consider the first name as valid because the user the user hasn't entered the field yet. So you can see here that should be removed because the first name is valid, it's already true. And we also have the error message. Every time we try to subtract a new value here, the error message reacts to the first name is valid. So this is an example of another computed or derived state depending on another derived state. So in Mobx, you can structure your app the way you like it to. It's very straightforward. And the last name doesn't have any fancy functions like that, but this works the same as well. And the last computed value that we have here is the is registration button enabled. So this registration button as well has its own observer function that subscribes to this value. And this is registration button is depending on the value if the first name is valid or if the last name is valid. So if you try to look at the example, we have here, I'm just opening the page. We have here the observer button. Every time the value is enabled, it will pass the function complete registration. But if it's not enabled, then we just have to pass null, which indicates that this raise button should be disabled. That's how things works in Flutter. There's no disabled or enabled parameter. And if you're wondering how this text field is passing, the first name and last name to our store file, well, we have here the controllers. So in Flutter, we have the text editing controllers in which you can instantiate at the very beginning of your page. And these controllers can be managed in a single place. And every time there's a change in the value, you can just simply call the store file to enter the first name or enter the last name. And this actually has a bug. So last name controller text. So every time I try to change the value in the last name controller, it should enter the value in my last name. So if we try to finish this up, try to register the user, we'll just see here that the parameter is passed to another page, but we're not seeing any navigation in the button. So what happens here is we have a reaction. So in the reaction, like every time the user finishes the registration, this simply reacts to the changes. So if the user has finished or completed the registration process, then we can just simply redirect him to another page, which makes your app be more reactive because your navigation now also depends on the state value and changes of your store file, which is a cool thing because if you want to test your app, just simply do something like this. So this is the sample test file that we have for this registration store, and testing is a bit just like calling a plain old Java class. Instantiate the store file, just have to enter the first name and checking whether the values are added or not. So as you can see here, like the first name is the only functions that we called, but we never updated the is first name is valid. And the is first name is valid is false by default. So what happens is you get to test computed values as well in unit testing. So if the first name is Joshua, then it's valid. The store file here reacts in the unit test so that it will be able to check whether the first name is actually valid or not. So that's one of the cool things about computed variables. It makes it easier for testing as well, so that whether it's a side effect or not, the state of your application can be predictable as they should be. And last example here is users should not proceed if the user registration has first name is invalid. So in here, you can see here, every time I try to enter the first name, which is below the minimum value that I set, which is 2, even if I have the valid last name, the registration completion should be false, because this should be reacting to the first name valid and last name to both true. So that's one way to test the edge case for that one. And the last thing that I want to discuss in Mobx is let me try to reset. One thing I want to discuss in Mobx in Flutter is that it gives you the architecture and doing API calls in a Flutter project. So in Mobx, mod by default, it doesn't restrict you from the architecture of the application. It just manages your state, whether it's just a simple widget, a simple screen file, or a simple feature scope. It doesn't really dictate the architecture of your app. So as you can see here, we have the typical folders that we would see on a clean architecture. We have the data sources that can be either from a remote data source or from a local data source. We also have repositories, which we can do additional mapping of our data or caching if we need to. And one thing that's not available here is the use cases, because it will be probably overkill for a simple trivia app. So this is a trivia application that retrieves the trivia from the API, and that shows us how reactive Mobx can be every time we try to fetch the data from the server. So again, the store file is really can be part of a screen, a feature, or a complex widget, and they don't dictate the specific architecture of your app. So right now, we're just waiting for it to be finished. So as you can see here, like we have a simple trivia function. Every time we call this should give us the trivia. But right now, since it doesn't have any actions to do that, or the query inside the action, this one, we should add it here. And the new API that I'll be showing you here is the Observable Future, which works great in Flutter, because if you're really working with a synchronous function in Flutter, you would typically have to use future for synchronous operations. And the difference with the future versus this observable feature is that observable features gives you this status, whether it's pending, whether it's already finished loading the data. That's part of Mobx as well. And to do that, to call the function with observable feature, you can just simply add it here. Now, this is the function get random trivia, and it has a bunch of methods here. We'll discuss in detail. So this is the method that we call from the repository to get the random trivia. And if you try to inspect this, like this is pretty much the basic HTTP call for getting a trivia. So in data source, we just get here the response from a list of objects, and from the JService API. And the repository, this is where we typically do the caching. But in our case, since this is a very simple app, just get the string or the trivia object. And one thing that you can do as well in Flutter or in Dart in general is that there's a package called either, which allows you to do functional programming even more better in Flutter. So instead of you trying to, for example, check whether the value is null or not, you can use this either either option package, and it gives you these functional functions that it checks whether the return value is on the left side, which we consider as a failure for now, and or the right side that we consider as a success result. So as you see here in the trivia repository, this can be either a failure or a trivia value. And if we try to check that, if the success block happens, the right data, the right represents the trivia object, and the left represents the failure. Which right now we're just returning a very basic server failure. Okay, there's some commercial behind. Okay, and now if we try and using this fold, we can just simply check if the failure is a part of the failure object that we instantiated, like server failure extends failure, so that it's also a failure object as well, and we get the error message. And the error message as well is an observable value, meaning every time there's an error, you could react to the changes in this error message. But if not, we can just set the value of the result from the API to the trivia result. And the trivia result is currently being used here. Let me try and get a quick. And one thing to maximize the potential of the observable future really is to create something like a store state. This is also a computed value. So as mentioned earlier, the future, which is observable future, has this future status. Whether they are pending or loaded or not, you can show the appropriate state of your application. The store state is just a simple enum clause that we created. If the future status is pending, you will tell the UI that you have to show this loading indicator because I am currently loading or fetching from the API. If the trivia future is null, meaning the function of the API call may not yet be called, so you can do whatever you like in the initial. Maybe you would like to disable some components in the very beginning, and loaded, if everything doesn't pass through this specific if statements. And one thing that we can do there as well is we just have to run again the build runner. So this build runner allows us to wire things up automatically for us with this computed annotations and the variables that we have here for the state. I'm gonna try running it. It's already running. Okay. Should be finished. Okay, so it succeeded, meaning we already have the state as part of our store file in the generated code. And if we try to restart this, like hot restart this one, we should see a trivia from now. Okay, that's here it's a bit jarring. Every time you see it just pops out. It's kind of like not the good experience that you would typically have to show to your users. And as you can see here, what that happens because there's no loading indicator for that specific event every time it happens. So what happens here is just it reacts whether the trivia result is null or not. So it just automatically switch from a container, no trivia available, to the text that contains the trivia question. So try to press it again. It just pops out without any loading indicator, which is not the user state that we want to, user experience that we want to bring to our users. So we need to subscribe whether the API call is loading or not. To do that, we can just simply add this function or add this parameter or variable. And another good thing here is that instead of us trying to create a pure function that calls whether this API is loading or not, we can just simply tell or react to the changes of the state, which is loading. So if the state is a store state loading, meaning this part, and pretty much we can do our thing in the widget. So that should be auto-generated as well. And for us to be able to add a loading indicator, we just really have to replace the entire block of observer with an animated switcher. So an animated switcher in Flutter is an implicitly animated widget, meaning if the child widget is changed, depending on the value of the specific variable, in our case, whether it's loading or not, then it will react to the changes. At the same time, it will show a transition between the two objects, such as the circular progress indicator and the text that contains the trivia question that we have. Try to restart it. Okay, now if we try to get trivia, as you can see here, it automatically shows the circular progress indicator without us having to like check whether the API is actually loading it or not. So try to get the trivia, get more trivia. And this is just the beginning of managing state in Flutter using Mobx. Like, you can also do something like this. So for example, if you want to not depend on the trivia result by default, since you're just really concerned whether this will be displaying a question or not, then as much as possible, you should stay away from doing logic like this in your widgets, but rather give this as a responsibility to the store file. So what we can do here is to create another computed value. The computed value, since we're just interested in the question, we can just do something like this. So we will check first if the trivia result is null. And we will get the question from there. Otherwise, we will show an empty string. And we'll just have to run the code generation again. And instead of you having to do various logic in your widget file, you can just simply call store.question. So right now, it's still rebuilding, but it should work the same way as it should a while ago. So it's still rebuilding. Do we have any questions? Okay, let me just try to increase the font. Okay, let's just wait for it to finish. But basically, this should be almost similar, not functions the same way, because we just, instead of us having to react whether the trivia object is null, we're now just allowing the Mobx to react for us, and we're just reacting to the derived state of your application. So right now it's a bit finished. So we try to press hot restart. This should function the same way. It's a bit slow here right now. Okay, and this should display the trivia. Okay. Probably internet is a bit slow. Okay. And one of the cool things about Mobx, on top of the practical things that we have discussed, is that Mobx doesn't really dictate the architecture of your app. So Mobx is just really tied on how you model the data that you want to display, or the information that you want to your user to interact with in your app, or a specific screen, specific feature, or a specific complex widget. Learning curve in Mobx is fair. You don't have to implement the observer pattern on your own, but it's a good thing that you should have a good understanding how reactive applications should work, because otherwise you'll probably create probably an app that is not performant. It's reactive by default, which works great with Flutter, which also follows the same reactive principles. Like every time you call set state, it just reacts to the changes of the state object value. And now with Mobx, it gives you this power to separate the business logic of your application from your widgets, which makes it easier for you to test small units of your application without you having to inflate a bunch of widgets of your app. And now echoing the best state management, really you just have to identify what you need and what you have. Really just determining what you have in terms of like the projects that you want to build, the budget that you have, the timeline that you set. Choose what works best for a team, because this state management will define how you would typically build your application, whether you're going to build it in a much slower or faster way. That affects your developer experience and productivity of your entire team. And be open. Do not try to bash other state management, or do not try to brag about the state management that this works great on top of that state management. And just be open. In Flutter community, we keep things a bit more healthy, just like other communities such as Android. We really want to keep things healthy for everyone, so that everyone feels, especially newcomers, feels they're welcome to ask questions from the experts in the community. And yeah, I'm open as well for any questions that you may have.